All right, so now we've talked about pretty much everything you could have with a trig function, with finding something in the unit circle and wondering where it is on that unit circle. So now we're just going to do little pieces. Okay, we're going to talk about some of the other things that could pop up. Okay, but we're only going to find one of them. We're not going to find all six. The process is pretty much the same though. So here they've asked us to find just cotangent of 45 degrees. Let's go ahead and draw ourselves a 45 degrees. I think I'm actually just going to zoom in on each one of these problems. So here is that 45 degrees, which means 45-degree triangle. Didn't even have to adjust this one, right? I've got 1, 1, and root 2. No negatives needed. So cotangent of 45 is going to be 1 over tangent. So maybe it's a good idea to go down here and do tangent first. 1 over 1, flip that 1 over 1, cotangent would be 1, okay? So draw the angle, draw the triangle, find the regular function you needed, and then invert it for the inverse trig function that you need. Not too bad, not too bad. We'll go over here now. Ooh, extra step here. I've got pi over 3, cosecant of pi over 3, instead of just regular cosecant of some degrees. Now, you may remember which one they are. You could also check your cheat sheet, but, you could also just convert it back. If you do figure out that cosecant of pi over 3 is cosecant of 60. Okay, so cosecant of 60 degrees. Let's go ahead and draw that 60-degree triangle. 60 is a little bit more than halfway between 45 and 90, right? And so we have our 60 degrees there. Now remember, just because we know 30 degrees is in this triangle doesn't mean we're looking from 30. We're always looking from the angle that's in the circle, in the right next to the origin of this quadrant system. And so we've got root 3 over here, 1 there, and 2 over there. And so cosecant, well, I know cosecant already has a co in it, so this must be the inverse of the one that doesn't have co, secant of sine of 60, which would be root 3 over 2. So the inverse of that, cosecant of 60, is going to be 2 over root 3. But I got to rationalize that, meaning root 3. In other words, 2 root 3 over positive 3 would be my answer. All right, cool. Now here's the thing. I know some of you at this point are like, ooh, I'm so smart. I see that there's a sign button on my calculator. I'm just going to hit that button and figure out what it is. Joke's on you. We're not going to accept decimal answers. Haha. No decimal answers. Decimal answers are not as accurate as a root. And so unless your calculator spits out roots, it's not helpful to you in this situation. You need to actually know what you're talking about. And you know how much we love to make you explain stuff. So make sure you know how to explain all this stuff. All right, let's head on over to secant 300. Again, we're going to draw that 300 degrees is a little bit after 270. And so we've got the other 60 here, right? Because this is the 300. And so the rest would be 60, thus completing 360. Across root 3 with 1 and 2. But this time it looks like it's not in the first quadrant. And so we're going to have to tack on that negative for the negative y values. Not for the x's, because the x's are on the positive side, right? We're not in the double negative zone, just the negative y's. All right, secant doesn't have a co in it, so cosine must be its opposite, must be its inverse. Cosine of this, adjacent over hypotenuse, is, and then you've got secant of 300 would be 2 over 1. Now here's the thing, if you don't want to write down cosine, that's fine. You could just invert the SOHCAHTOA. So if you don't want to have to write down cosine 300 is 1 over 2, that's fine. You can just say, all right, secant is opposite of cosine. Cosine is adjacent over hypotenuse, and so secant must be hypotenuse over adjacent. That's fine too. You can bypass this step altogether. That's not how my brain thinks, but I like that our brains don't always think the same way. So I like to write down this. Some people just go straight to hypotenuse over adjacent. Other people, they're so ingrained with SOHCAHTOA, they don't want to mess that up, okay? So that's totally up to you. Let's try, we'll do both over here, just so you know a little bit more of what I'm talking about. Cosecant of pi over 2. For those of us who don't remember, pi over 2 is the same thing as 90 degrees, but you could figure that out if you were to convert it using 180 over pi. Alrighty, and that's right here. Uh-oh, situation. I can't draw a triangle. I can't draw a triangle here. There's no way to drop this back to the x-axis and draw a 90-degree triangle. You can't have two 90s in a triangle. That makes no sense, right? 90 plus 90 is 180. The third one's 0? That makes no sense, right? That's a straight line. So we can't do that here. Instead, let's play more on the circle idea, in which case this would be the point, whoops, pardon me, 0, positive 1. Cosecant, opposite of sine. Sine is the y, and so this would be cosecant. Let's just write that again. Cosecant of 90 would be 1 over the sine. The sine in this case is 1, and so it is still going to be 1. We get cosecant of 90 is equal to 1. Okay, so yes, we had a cosecant of now what was one of those special cases, but the special case didn't matter because we already took care of that in the sine version. We just got to take what we get for sine and flip it upside down. All right, let's do it again. This time we got another one, 270. We know that's not going to give us an angle either. Oh, wait a minute. That's not sine of 270, is it? That's sine of negative 270. Fascinating. What does that mean? Well, if you think about it, we're talking circles. What happens when circles go in the other direction? What happens when circles go negative? They go in the other direction, right? If circles rotate this way positively and keep rotating this way positively, they're going to go this way when it's negative. And so it's the same idea, just, hey, negative, backwards, right? Kind of like this way's positive and that way's negative. And so we're going to take this 270 and we're going to draw it backwards, 270 degrees backwards. Now we're going to do the same idea. Sorry, this should reach the line here. The same idea as when we went over on the circle. In a couple of videos ago, we went over on a circle and we said, okay, well, that's fine. We had 720, but that just means we went back to 0 and we got the same thing as 0 degrees. This is going to be the same idea. We're going to treat this like 90 degrees. So this is going to be the same thing as sine of 90 degrees. A positive 90 is the same thing as a negative 270. A positive 30 is the same thing as a negative 330. Okay, it's going to be just the other half. Okay, they add to 360, if you see what I mean. The only one that would match is 180. Negative 80 is the same thing as positive 180. Cool, so we've got sine of 90 now. And again, we have a special case. We have 0, 1. Sine here is going to be, so sine of negative 270 degrees is equal to 1. Just like it would be if we were going forward. They're going to end in the same spot. Cool. Let's try another one of those negative outs now, or negative ones. Here's negative 30. So here's my 30 degrees, right? No, that's positive 30. We want to go down 30 this time, which is going to be the same thing as a positive 330. But here's why it doesn't matter. Do you remember what we did to find 330 degrees anyway? We took the other 30. We dropped this triangle back anyway, and we grabbed that other 30 degrees. And so at the end of the day, no, it doesn't matter which direction you go, as long as you remember that the negative ones go down, the positive ones go up, okay? All right, to begin with, I should say. All right, so now we do this. 30 degrees gives us that 30, 60, 90 triangle. 30 is across from the smaller side, and with the bigger side, hypotenuse of 2. Cosine of that, so it's cosine 330. All right, cosine of negative 30 degrees is equal to opposite over that hypotenuse. It's equal to 1/2. Sweet. All right, let's look at another one here. Now we've got tangent of 780. Okay, that's definitely bigger than 360. So when we go to graph this, let's go ahead and graph. We know 720 is 2 circles. So there's 1. There's 2 circles, and then if 720 to 780, it looks like there's about 60 left over, and so it's going to go out about that much more. But here's the thing. Who cares that it went twice around? Nobody. Nobody cares that it went twice around already. All we care about is that this is a 60-degree triangle left over, and so we can use that 60, 30, 90 triangle. So basically the number of times it goes around, that's important in physics. It ain't so important in trigonometry, okay? All right, so 60 would be across from the bigger side, 1 and 2. Oh, heck, I'm so sorry. You're probably wondering, like, Miss K, there's an error over here. What did I do wrong? This triangle's not in the first quadrant. Miss K, 2 out of 3. Minus. It would be minus 1/2. Pardon me on that. This one, it all is in the first quadrant, so that's all positive. I apologize for that. All right, we go over here now. We've got tangent of 780, this circle here, this double 2 and a something circle here. Tangent would be root 3 opposite over adjacent, or just a positive root 3. All right, moving right along. We've got tangent negative 390, also over 360, but this time in the other direction. So we've got 360 this way and an additional 30 this way. So this is 30 degrees negative now, which means it's the same thing as a tangent 330, positive 330. Okay, not going to make the same mistake twice. This is going to be across from the 1, but it's negative this time. Root 3 will be positive. Hypotenuse is always positive. So the tangent here would be opposite over hypotenuse, or negative root 3 over 3. Okay, I'm going a little bit faster, but luckily it's a video. So if you do have any questions, please make sure you pause and you ask your teacher. Okay, I don't want to have you spend 3 hours watching these videos because I'm going really slow. I go a little fast in the videos on purpose so that you will go talk to your teacher if you get confused. We're going to do the last two, kind of bonus problems, and then that'll be it for 6.4. After this, we'll have a quiz. All right, so let's say you get this horrendous thing. Secant of negative 135 pi over 36. Yeah, I don't even know what that is. So let's go ahead and convert that to degrees. Times that by 180 over pi, even though it's crazier looking, right, than like 240, it's still 180 over pi, always 180 over pi. Okay, and then we'll cancel that down. I see maybe 6, 30. Just kidding. We can do 5 and 1. What's negative 135 times 5? This is the same thing as secant of negative 675 degrees. All right. There's the first thing you can run into. It's a radians you don't know. You convert it. Second thing you run into, the tie between it's over 360 and it's going backwards. But I can fix both of those problems at the same time. So I know I'm going to be going this way. Definitely at least once, if I take 675 and subtract 360 out of it, I'm back to 315. Here's 0 and 315. Now be careful. That's a negative 315. So don't like stop there what you know to be 315. We still have to go almost a full another circle. And this ends up going back to 45 degrees. All right, so this is going to be the same thing as secant 45. Cool. Now it's 45, so I know it's got sides of 1, 1, root 2. Luckily, first quadrant, no negatives. Whoosh. Okay, good. So no negatives there. I need secant. Secant doesn't have a co in it, so I'm going to need the cosine, which would be adjacent over hypotenuse. In other words, I need hypotenuse over adjacent. If you didn't quite catch that, I need cosine of 45, which would be, 1 over root 2, aka root 2 over 2. And if I flip that for secant negative 135 pi over 36 is going to be root 2 over 1, or root 2. All that work to get down to root 2. Isn't that crazy? But that's pretty much worst case scenario. Like, about as crazy as it gets. Last one. Recommend you try it on your own. See what you come up with. I'll give you 5 seconds to pause the video. All right, hopefully you paused it. 1020. How many circles is that? 1020 minus 360. It's at least 1. We're left with 660. Take out another 360. And we're left with 300. So it's almost 3 circles. But what's left over? Another 60. And so we can draw a 60-degree triangle. My 60 degrees always end up super like long. I don't know why. All right, 2. And then across would be the shorter side, root 1. I'm sorry, no, it wouldn't. It would be root 3, longer side. 1 there, and it's a negative root 3. Cotangent is going to be the opposite of tangent, aka adjacent over opposite, which would be 1 over negative root 3 or negative root 3 over 3. Hopefully that's what you got as well. All right, looking back at all of that, it's a chunk of work, okay? You first have to figure out if there's anything special you need to take care of. Is it negative? Does it go over 360? Is it radians? Once you do that, you can take care of that, put it somewhere in between 0 and 360. Draw the angle. Draw the angle, create your triangle, if possible. If it's a special case, you know what to do. Create the triangle, find the trig you're after. That's all it comes down to. The last video for this section, we're going to go ahead and fill in just a little bit more of that cheat sheet. Actually, we did from the beginning. I apologize. We don't need to fill in anything more of the cheat sheet. If there's anything you'd like to add to this, you're more than welcome to. Cheat sheet is a misnomer because honestly, it's an open note test. So really, this is just a condensed version. That's really all it is. Feel free to add whatever else you want to this. But we will not have another video as we've already filled in the inverse functions, which is what I wanted to fill in anyways. So I will see you in 6.5. Have a good time till then.